Hi, guys. Okay, so let's do the exercise problems from chapter 5, ionic compounds, from the introductory chemistry book by Tro, which is on the Libre text. Okay, so the very first exercise problem is 5.4.1, and here we are given iodine, helium, water, aluminum, and copper chloride, and we're being asked to identify if they're atomic, which one is the atomic element, molecular compound, molecular element, and ionic compound. Now here in this question, you have to understand, first of all, the term atomic and molecular. So atomic and ionic actually also. So molecular, atomic, and ionic. Atomic is just one single element that you see in the periodic table. So that's just single one element, one atom of that element, atomic. Molecular is when two atoms are joined together. Okay, moleculars are when two atoms join, two or more join together in a very definite ratio. That is molecule. Now, even in the molecule, there are molecular elements and molecular compounds. Now, what is a molecular element? Molecular element is when the same atom combines to itself. When the two atoms are the same and they combine together. And these are mostly nonmetals. So nonmetals such as oxygen, two atoms of oxygen combining themselves, they'll make O2. Two atoms of nitrogen combine to themselves or bond to themselves, that'll be N2. Then one atom of chlorine and one atom of chlorine combined together, they'll make Cl2 and so forth. So both the nonmetals, both the atoms are non-metallic and they make this molecular compound. Same, both of them are the same molecular element. Next is the molecular compound. Molecular compounds are the two atoms are different. The two atoms are two or more atoms, but they are different and they are non-metals. Like for example, carbon and oxygen combined together, hydrogen and oxygen combined together, water and like water. So those are molecular compounds. Ionic compounds are metal and non-metal. So metal will have a positive charge, non-metal will have a negative charge. So keep this in mind that the term, the way we have categorized is, when we talk about compounds, we are talking about the two or more different type of atoms are bonded. Okay. If they are covalently bonded, then it's a molecular compound. If they are bonded by the ionic bonds, by the transfer of electrons, then it is the ionic compound. So molecular compounds, nonmetals, and these are the two or more different nonmetals. Ionic compounds, a metal and a nonmetal. Okay, so this is how we put it. Now we are going to write this, identify these. So iodine, I2 is the two atoms together. I mean, it's weird to say element, but it is an I2 molecule, iodine molecule. Okay. Atomic element is helium out of this choice. So it's only one atom, right? Next is aluminum, also is just one atom of aluminum. So these guys you will see in the periodic table as it is, as the elements. Okay. Now, next is the molecular compound, like H2O. Here, water and oxygen are combined by the covalent bonds. Okay, so here we will have covalent bonding in the two or more nonmetals. Okay, when two and more nonmetals mix. TALS. Okay, now comes the ionic compound. Ionic compound is always like two or more when a metal and a non-metal, when they mix together or when they bond together. So they make ionic bonds, and these are formed by the transfer of electrons. So transfer of electrons. Okay, let me just put this here. Made by the transfer of electrons. So there's not much space. I don't want to overlap this. Transfer of electrons. So which one is that? A metal is copper and the other one, chlorine, is a non-metal. Okay, so these are the answers to these questions. Next is the, so let's just put this here. Copper chloride. Okay. Next is, what is the formula of calcium ion when it combines with the when it combines with the oxygen ion? So calcium, so here's the rule. You are going to look at the group number in order to write the formula. Look at the group number, look at the valence electrons, and those determine the charges. Okay, so here calcium is in group 2A. Calcium is in group 2A, sorry, group 2A and 2A. Number of valence electrons are 2 valence electrons. So the charge, because it's a metal, the charge is positive 2. So calcium will have +2 charge. Oxygen is in group 6A. So the charge, and it has got 6 valence electrons. So the charge is -2. So this becomes oxygen -2. Now here we're going to write it. So here you have calcium with +2 charge, and you have oxygen with -2 charge, and you're going to crisscross. Crisscross means this number comes here and this number comes here. And when that happens, what do you get? You get calcium 2O2. Basically, +2 and -2 cancel out. So you don't bring the negative and the positive charges down, but you just cancel these. So now you have, so you always have to bring a simplest, always have to bring the simplest whole number ratio. So that is why the cancellation. So now the final formula is calcium oxide, CaO. Okay. Next is copper 2 and sulfur ion. Now copper with +2 charge. Remember, copper can be cuprous and cupric. Copper can have +2 and -2. So anyway, so here we have, so same thing, copper, if they have given you +2, then just put it +2 here. Now sulfur. Sulfur is in group 6A. It has got 6 valence electrons and the charge is -2. So this is something you have to memorize. And all this has been given in the lectures. Okay, so sulfur now has -2. So now we are going to put here copper +2 charge and sulfur -2 charge. So just like we did above. So we are going to put 2 here and the other 2 here. But they are going to cancel out 2 and 2, same. So what do you get here? So CuS. So +2 and -2 cancel. Same charges cancel out. Okay, so this is the formula, CuS. Next is copper 1 with sulfur. So here copper 1 is +1 charge. Same story, sulfur is -2 charge as above. So just put here copper +1 and sulfur -2. And now you're going to do the crisscross. So this number comes here and this number comes here, but you're not going to bring down the negative charges. So what do you have now? So you have Cu2S. So for 1, we don't write. So you're going to just remove this 1. So Cu2S, this is the formula. Okay. Next is the formula of sodium bromide. So same information that you need. So what do you need information here? You need to know the group number, valence electrons, and based on that valence electrons are the charges. So let's do this. Sodium is in group 1A. Bromide, ide. Remember this, ide is the single ide. All these ides are here also. We did this. So this was just, they're asking you to write a formula. But the name here is, I'm still going to write a name. This is calcium oxide. Calcium, just the name as it is, calcium oxide. Okay, calcium oxide. And then you have copper sulfide. Oh, the name is copper sulfide because it's just a sulfur just by itself. Sulfur like a non-metal just by itself. So sulfide, IDE. So you see the IDE is always goes if there is a non-metal just by itself connected to a metal. So here we see, so bromide is coming from bromine. So bromine is group. So this is sodium, Na. Okay, bromine is Br. So this is in 7A. Valence electrons are 7 valence electrons, but the charge is -1. So what that's forming now? So the charge on sodium, so valence electrons on sodium is 1 valence electron and the charge is +1. And again, you have to watch the lectures to get this. So this one is just practicing. So sodium +1 and bromine -1. Okay, so when they crisscross, they are just going to form Na plus NaBr because +1 and -1 cancel out. Same charges cancel out. So this is the formula and the name. Next is the lithium chloride. Same story. Lithium group 1A. Okay. So I'm going to just put this here. Charges and the valence electrons and the charge. So lithium is group 1A. Valence electrons is 1 valence electron. Charge is a positive charge. All metals will have a positive charge. Chloride is coming from chlorine, which is in 7A. Okay, lithium looks like Li, chloride looks like Cl. Okay, 7 valence electrons, all 7A, all the elements that are in group 7A, 7 valence electrons, the charge is -1. So here you're going to perform lithium with +1 charge and chlorine coming from chloride, like coming from chlorine, -1 charge. Once again, plus and minus cancel out. So what do you get? LiCl. Okay, next is magnesium oxide. Same story. Magnesium is 2A, 2 valence electrons, +2 charge on magnesium. Oxygen is 6A, 6 valence electrons and -2 charge on oxygen. So let's put this here. Magnesium +2 charge, oxygen -2 charge. They cancel out. So the formula is magnesium oxide because +2 and -2 cancel out. Okay, so cancel. So I'm going to just put this here. This also cancels. So wherever the charge are canceling, you don't write them. Okay, so these are the formulas and the answer. So the answer here is magnesium oxide, lithium chloride, NaBr, and the top one is Cu2S, Cus, CaO, and I wrote the names also, calcium oxide name and copper sulfide name. Okay, all right. Next is the formula of magnesium with carbonate. Now we are looking at the polyatomic ion. So this is something you have to memorize. Carbonate is CO3 -2. And magnesium is in group 2A, 2 valence electrons, charge is +2. So we are going to write down here magnesium +2 charge. And now same story, +2 charge and -2 charge cancel out. So what will you do here? You are just going to write down MgCO3 and that's it. That's the answer. Okay, next is aluminum ion with acetate ion. Now that's an acetate ion. Acetate ion is CH3COO with a negative charge. And this also is written as C2H3O2 -1. This is also written like this. So it's the same thing. Okay, aluminum ion. Now aluminum is in group 3A. What is a charge? Valence electrons are 3 valence electrons. Charge is +3. Okay, so +3 charge. So now crisscross. So let's do this. I'm going to just bring this one here. So here is C2H3O2 and here's the aluminum. Aluminum is here. Okay, so what are we doing here? We're going to take this here and we're going to take this here. Okay, so what do you get here? Al. So every time when more than one charge is crisscrossed or carried over or crisscrossed, then the polyatomic ion is put in the parenthesis. So PAI, the polyatomic ion, acetate ion is a polyatomic ion. So now because you're bringing 3, so this guy C2H3O2 is going to go in parentheses. Otherwise, you will be writing the number 23. That doesn't make sense. Remember, when you crisscross, 3 is coming to the base of the acetate ion, but acetate ion has to be first put in the bracket and you put the 3 outside. So this is very important. Okay. So this is the answer. Next is the identify ionic and non-ionic. Now, ionic, remember, ionic compounds are always metal, one metal. So you should recognize a metal and non-metal, or a metal and a non-metal, or a metal with a polyatomic ion. So that's the ionic. Okay, metal when combines with a non-metal, or metal when combines with a polyatomic ion. In that case, it produces the ionic compounds. Okay, ionic. But then molecular. Molecules are when the non-metals just combine to themselves. When non-metals bond to themselves, then they produce the non-ionic. Okay, non-ionic is that. So non-ionic is covalent. Okay, so here what do you see? So the whole thing is whether you recognize a metal or not. Iron is a metal, right? So iron is a metal, and ammonium phosphate. Now that's a tricky one. These are the two so definitely let's put this here. This is going to be, this is ionic because metal and a non-metal. Next is N2O. These guys are actually the N2 is non-metal and oxygen. Nitrogen is non-metal. So two non-metals are combining. So this becomes non-ionic. Okay. And when you look at the SOCl2, so this one also, sulfur is a non-metal, oxygen is a non-metal, chlorine is a non-metal. So in this case, we will see that this is also non-ionic or covalent, basically non-ionic. And then now comes the tricky one, and that is the polyatomic ions. So when two polyatomic ions, so remember, this already ion. So this is ion, phosphate ion. This is ammonia. This is also ionic. So all the polyatomic ions, even if the polyatomic ions combine together, they're still going to be ionic. So keep that in mind. That, let me put a note here, that polyatomic ions bonded will also be ionic. Okay, so it is going to be an ionic bond. So this is the story. So ammonium phosphate is basically ionic compounds. Two ions combined together obviously will make ionic. Okay. All right. Next is the name. Now naming. Now this is the this is for your memory. So you can name it as iron 2. Because iron exists in +1 state, in +2 state, in +3 state. So that charge represents this. This is represented as or shown as a Roman numeral. Or you can also call this the us. The lower oxidation state or a lower charge is us, and the higher is ik. Okay, lower is us, and the higher is ik. Lower is us and higher is ik. Okay. Next is sulfate. This is the sulfate. So this is all by memorizing. So basically, you need to memorize the polyatomic ions so you can recognize them. So this is sulfate. But if it was sulfite, ITE, it would have been SO3. Next is iron 3. So you're still going to write down as iron. This is one way of writing. Iron 3 is this. And you can also go ferric. Now, I have given a handout which you can use. All the tables are there. They're the tables for the polyatomic ions. There's tables of the elements that show more than one type of positive charge. There is this entire periodic table. So you have to memorize, okay? And there's no choice. There's no choice. This is the language of, so this is the barium. Now, barium doesn't show barium does not show variable positive charges. So therefore, barium will have barium is just written as barium. Next is this one is the bicarbonate. Now you can also call it hydrogen carbonate. Either way, bicarbonate or hydrogen carbonate is the same. So this question relates to, memorization. Next is the formula. Similarly, now remember, formula fluoride, remember IDE, that means it's the fluorine, that's the name. So it's the fluorine with one negative charge. Okay, fluorine is in group 7A, -1 charge, that's the charge. Next is the carbonate. Once again, memorization, carbonate -2, CO3 -2, stannous. Now us and ic, remember us stands for tin. So this is stannous is tin. So this is tin, and it's a lower oxidation state for tin. Tin exists in 2 oxidation states, 2 charges, +2 and +4. Okay, so +2 is lower, +4 is higher. So here, or you can also write down SN +2. So again, you have, this is all memorization based. Potassium ion +1 charge, group 1A. Okay, so I'm going to make a note of it, that how to answer these questions. These are based on memorization. So something you need to know, and all this is refer to the handout for the tables, and you have these tables, so just have to memorize them. Same is the case, this also, memorization. And memorize tables in handout on polyatomic ions. Okay, all right, so this, let me put this here, charge. So, okay. All right. Next is, now we are looking at the naming of the non-metals. So what is the naming of this one? Carbon. So carbon. So for the non-metals, when they are bonded, when we use the di, tri, tetra. So this one is tetra, 4 is tetra, and fluoride, FLUORIDE. Okay. Next is selenium. So recognize that, selenium dichloride. So selenium dichloride. Okay, so non-metals, we use di, tri, tetra, and I just want to make sure that, because selenium is in, it's interesting. It is, I don't know if selenium is a non-metal. It looks like by this chart, I see it looks like, yeah, because it's on the others, it's near astatine, which is a metalloid. So selenium is okay. And then comes the sulfur. So this is sulfur, SULFUR. 3 oxygens are there, trioxide. Okay, so this is the terminology for the non-metals, di, tri, tetra. Okay, the last question is finding the formula mass. So what are you going to do here? This means this 3 applies to iron. This is iron phosphate is given to you. 3 applies to iron. This 2 applies to phosphorus. This 2 applies to oxygen. Okay, so what do we have here? So we have 3 irons, and we have 2 phosphorus, and 4 times 2. So that makes 8 oxygens. Okay, there are 4 oxygens and then 2 from outside the bracket. So this is 8 oxygens. Now you're going to look in the periodic table and you're going to find the weight of iron. So iron is 56. Okay, 56. Oxygen. So here for now, I'm going to put atomic mass units. Phosphorus is 31 atomic mass units, and oxygen is 16 atomic mass units, and it's okay to round up. So here, whatever the numbers you get, you add all those numbers up. So after you add all those up, that is going to be your, this is also called a molecular weight. Molecular weight. Commonly, in several books, you will see this is a molecular weight. This is also called a formula mass. Formula mass, and we also call it, commonly known now, is the molar mass. Molar mass is more common now. So the units for the molar mass is grams per mole. Okay, formula weight, atomic mass units, formula mass, atomic mass unit. So these are older ones, but for this is the molar mass. So when you add all this up, what answer do you get? You get the, I don't have the answer with me, but you get an idea. So you're going to add this up, and then that gives you your, let's see if I can get it. 1 minute. .11, and that is, okay. So yeah, so actually for this 5.11, yeah, 5.11, there were the 5.11.1, actually they gave you 4, but they did not do for iron phosphate. So I have done it for you. And then, you know, the rest of the other 3 are given. So you should practice that. Okay. All right. So, okay, so we get 358 atomic mass units. When you multiply 3 times 56, it gives you 168. 2 times 31 is 62, and 8 times 16 is 128. So this is your final answer. Okay, so this finishes the exercise problems from chapter 5. But these are just, you know, simple ones. Very simple ones, just for practicing more, but you really need to do the worksheet on nomenclature, which is going to give you more practice. All right. Okay. Thank you. Bye-bye.